So hello everybody, welcome to our webinar. My name is Chaim, I'm a business development manager at CloudZone. With me is our very talented data engineer Elad Rabinovich, which is going to tell you all about streaming Oracle databases for cloud analytics. I hope you guys enjoy. This will be our agenda. I'm going to tell you just a little bit about CloudZone just to get you into context, and then right after me, as I said, the streaming Oracle databases for cloud analytics by Elad. Right after that, of course, as usual, we will have some time for questions. Let's go. So CloudZone is a multi-cloud solution provider and professional services provider in Israel. We run consolidated accounts for our customers, and we implement technical support by our very talented team of solutions architects. And we provide cost monitoring and FinOps services as core service to all of our customers. We are also, of course, a daughter company of Matrix, which is the Israel's leading IT company with more than 10,000 employees spread worldwide, and that are providing a variety of solutions in fields like financial operations, web and application development, data management, and all around of expertise. CloudZone, as I said, providing consulting, operational, and delivery services in cross-sector industries and any vertical. And from startups to enterprises, we're ready to confront any of your cloud challenges. In terms of AWS, this is our list of competencies which allow us to provide professional solutions. And according to regulations, of course, we were also chosen as DevOps partner of the very easygoing year of 2020. And this is our cloud expertise, our CloudZone expertise. So from machine learning, AI, and IoT, we are ready to confront each one of these of a professional buzzword out there in the market. CloudZone is constructed of a very capable DevOps team, solutions architect team, very talented, as I said, FinOps team, project managers teams, which deliver project by project at any scale, and of course our data team, which is hosting us today. We provide cloud projects in any area of desire, as you saw, and which corresponding to our list of very long list of competencies. CloudZone is defining today data management and business intelligence as the main cloud operations accelerator, starting from driving intelligence forward, implementing tools to collect data and digest the data, and integrating third-party tools in order to complement the entire solutions that we bring and providing to our customers. It could be native cloud resources or create a data-driven production flow for each industry vertical, ending with an AI operation, which servicing our main goal which is driving business forward. Just let me conclude with this last slide, at least from my part. So right after the webinar, you're welcome to contact us today through any way. It can be my email or through our website, and schedule a qualification session. And if qualifies, of course, sorry, we will be ready to fund full POC and start a joint cloud journey. So again, thank you for joining us today, and let's go to the main part. Elad, please take it from here.
Hey, lovely people. Thank you again for joining us, and thanks to Chaim. My name is Elad Rabinovich, and I'm a data engineer here in CloudZone. I'm working with CloudZone for the last 3 awesome years. And here in CloudZone, we are working with diverse range of customers from all fields. We have encountered with not few challenges and interesting projects on the way. In this webinar, I would like to share with you one from many of our experience with moving data from on-premise into the cloud. And this time we're going to talk about Oracle DB, moving to data warehouse Snowflake. And since we are living in the age of digital transformation, I'm pretty sure that you will find this content relevant for you, and you will be able to have a grasp for moving data into the cloud for analytical purposes. Let's cover our agenda. First of all, we're gonna have a short background about data analytics. Next, we're gonna talk about CDC, capture data change. It's a great technology for that will help us on the way. We will talk about it, and of course, with the focus on Oracle DB. We will talk about AWS DMS data migration service. It's a great tool for replicating data, and it supports CDC. We're gonna talk about DMS with the context of CDC and Oracle and the challenges that we encountered with. We're gonna talk about Glue. Glue, it's a serverless data integration service that make it easy to perform ETL pipelines, and so we will cover that too. And in the end, we're gonna see how we merge data into the data warehouse using Glue Spark job that will help us to migrate the data from the on-premise to the data warehouse. And of course, we're gonna see another alternative for this solution. Let's start with the background. I think as a data person, you are all aware that data properly analyzed on a daily basis can provide the insight necessary to make a well-informed decision and achieve a competitive advantage for an organization. Data analytics, it's the process of collecting, organizing, and analyzing large sets of data that it's relevant for a business with the target of answering relevant questions for better decision making for an organization. And if it can be done quickly as possible, even better. Nowadays, organizations have much greater collection of more relevant data than even before. This includes a diverse range of operational sources like relational databases, NoSQL, other external and internal system, OLTP system, the same like the others, but need to say that. Machine generated data like IoT, SaaS, and others. And since this data is scattered around the organization in different silos and forms, it's necessary to rearrange it, rebuild it, and remodel the data in order to achieve the desired data analysis for the organization. We're saying that one of the problems that rise the last years are the data silos phenomenon. Data silos is basically a collection of data that it's not available for the entire organization, but only to some part of it. It's controlled by one group or even individual employee and not easily and fully accessible by other groups in the organization. Data tends to be organized by department, if it's sales, marketing, and finance, and others. Those departments needs different information in order to do their job, and those individual collections are often overlapping or even inconsistent data that are scattered around the separate silo within the organization. As diversity and quantity of the data grow in the organization, silos continue to grow too, resulting in untransparent information within the organization. In a way, data silos are bad. Besides the fact that the silos can cause a limit productivity and waste of resource, in the age of digital transformation, when our goal is to enhance productivity, see the future, and discover hidden insight within our data, data silos hinder the process of data analytics in the organization and create a barrier to an holistic view of the organization, data, sorry. And in order to harvest the full benefit of data analysis, the organization need to have a full view of their data in order to get the hidden insights. So what we need to keep in mind from this slide is that data silos are killing our business analytics. Let's cover some of the major limitations on the way to a proper data analysis. As I mentioned before, data silos are a barrier that needs to be addressed to have data transparency within the organization for a better and accurate data analysis. Data sources are more numerous and varied, resulting more diverse data structure that must coexist in a single location to enable a full and affordable analysis. One of the limitation is a long analytical cycle. The traditional data pipeline are based on batch processing, something that we will cover really soon. And sometimes it can take hours or even days to build the data assets before it's available for analysis. On top of that, can be complex queries that can run even longer. In many cases, the storage and the compute resource required to process and analyze the data are inefficient. The traditional database, the traditional system to support big data analytics, it's another aspect because another aspects are added to the equation like volume, variety, and velocity of the data, which can cause a performance problem when processing using the traditional data processing techniques. The traditional database weren't designed to handle the volume, variety, and the velocity of the today's data. And the traditional architecture caused competition between the end user and the data integration activity that make it difficult to run simultaneously without causing a performance impact on one of them. Also, the pricing model. In the traditional pricing model is not agile, meaning you cannot be flex when it comes to provision the right hardware for the analysis task. You needed to predict in advance your workload and buy the right hardware for that. We can address those limitations with a data warehouse. Data warehouse is RDBMS that designed to enable a business intelligence activities like query analysis rather than OLTP use. It usually contains an historical data from diverse operational sources. It separates the location where the analysis is taking place on all the data that brought into it. And being an MPP system, it has the capability to cope with such analytical queries on such large volume of data. One of the key factors that driving the evaluation of the modern data warehouse is the cloud, which enabled near infinity, low-cost storage, improved scalability, outsource the data warehousing management and security to the cloud vendor, and potential you can pay only to the storage and the computing resource that actually have been used. The cloud architecture introduced the MPP, massively parallel processing approach, meaning dividing a single computing operation to execute in parallel across large number of separate computer processors, resulting much faster analysis than before. Also, the pricing model is changed. It's agile. You pay by query or by warehouse uptime. Also, today a rising pattern in the data pipeline is ELT. You're all aware about ETL, extract, transform, and load. ELT stands for extract, load, and transform, meaning performing the transformation inside the data warehouse after the loading phase. And the MPP enabled to do it with high performance. For example, we have a framework dbt that's supporting something like that. Okay, so next I will show you now one of our customer use case because it's a common solution and actually really interesting one that covers most of the items here that we're gonna talk in this webinar. This customer has different workloads around the world, and if you want data silos, it's Oracle DB, and they span around the world from Sydney to New York. And our task was to bring a specific data from those silos to a single location to data warehouse, to Snowflake, the data warehouse, for future analytics purposes. Let's take a look at the solution requirements. Ongoing near real-time data replication from on-premise to Snowflake. We need to support real-time. And remember that the traditional approach was batch processing that didn't enable us to perform a real-time data replication. We will talk about it. A raw data tier. Like in any common data analytics solution, we have first raw data tier before the data is being modeled. The requirement was to maintain a mirror table in the tier and keep them in sync from the source database to the destination. And later on, it will give us the possibility to do the analysis and exploration. The solution must be replayable. It means that if we had any data quality issues on the way, we can replay the data until the specific time that the data quality issue occurred, and to fix that or do something with it, to have the ability to rewind things. One of the things that we needed to solve is the time travel representation limitation. For example, in Snowflake, depends on your if it's in standard edition or enterprise edition, you have a retention limitation for time travel. Time travel is just that I can go to one point in time and get the relevant data from it. And we needed to have no retention. So we needed to solve this, we needed to answer this requirement. One of the most important is to avoid performance impact on the source database, meaning that we cannot interfere with the daily activities on the Oracle database around there. Security is really important when you're moving the data. You want to do it in a secure way. And data quality validation. In the end, we want to make sure that what we're seeing in the end in the data warehouse, it's accurate data, because if it's not accurate, we're missing the whole point of data analysis. So the challenge that we encountered with is how we keeping low performance impact on the source database. How we avoiding querying the database engine. We need to work with minimal supplemental logging. This is the first time we're talking about Oracle features, okay? Supplemental logging related to Oracle. We will talk about it. We need to support a near real-time data pipeline, meaning that batch processing is not something that we can use here. We need to monitor the data, like we said, must to be accurate, And we need to have a fast recovery mechanism that it will support that soon if there is any quality issues on the way, we need to address it as fast as possible. So let's get deeper to data processing. When it's come to big data analytics, there are two main ways to process data. The first, and it's more traditional approach, it's the batch processing. And the second is streaming processing. With batch processing, data is collected in batch and then fed into the analytics system within a specific time interval. Another term is often used is a batch windows. Batch processing is often used when dealing with large volumes of data or the data sources from legacy system where it's not feasible to deliver data in streams. Unlike stream processing, batch processing does not immediately feed the data into the analytics system, so results are not available in real time. It works well with data that's been archived and will be accessed periodically for historical purposes rather than to use to make an insight decisions. When we're working with batch processing, sorry, it can result a strain on the network and can have periodic spikes in the performance load on your database, resulting in slow production to allocate resources for the sync. On the other hand, we have the stream processing. Stream processing is the key if you want analytics result in real time. By building data streams, you can feed data into analytics tools piece by piece as soon as generate on the source and get near instant analytics result. And since we are moving the data piece by piece, the impact on the network and the source system is low. One of the things that make it possible to work with a stream is something called CDC, Capture Data Change. Let's talk about Capture Data Change. Capture data change, it's referred to a set of software design patterns. It's sets of technologies that allow you to identify and capture the data that has been changed on the database. CDC simply tracks the source dataset, it can be a table, and automatically logs the transaction and transfer those logged transactions changed to a target dataset, where the target can be either a table in the same database, a different database, a streaming data platform like Apache Kafka, Flink, or others, or even to storage or cloud storage. CDC is the approach to data integration that helps businesses to obtain greater value from their data by allowing them to integrate and analyze data in real time while using fewer system resources. Actually, CDC it's empower businesses to move at the speed of their data. Now, each technology achieve this behavior varies, but I would like to show you in abstract how the CDC transaction logs looks like and what we can do with that. In this example, we will construct a table from empty table to the end result of the table from the transaction log. On the left side down, we can see the list of the transaction log that have been logged. Operation, OP, it's the operation that made the DML operation. I stand for insert, U update, and D delete. We have timestamp, we have the ID, let's say the primary key for this table, and one of the columns name. Let's say that it's a table like customer tables or wherever we want to call it. So we're starting with an empty table, and yes, it worked. And now we are inserting, we have three operations of insert that we inserted those three items. Later on, after that, we're gonna see an update of the row number 2 with the ID number 2, where we updating to Lulu, as it's obvious, and the last one will be operational delete, where we are deleting the third item within the table. So now we saw how we can reconstruct or reflect one table from the CDC transaction logs, which have been captured on the source system, and we can reflect those changes to a table in the destination. Now, next, we will talk about CDC in Oracle DB. There are two ways how Oracle implement the CDC there. We have synchronous and asynchronous CDC. While with synchronous CDC, Oracle change data can be captured by implementing triggers on the source database table. It allowed the change to be captured immediately as each DML operation is made. And in this mode, the transaction is not closed until the database will capture the change and write it to the disk. It making seems like it real time with no latency, but we need to keep in mind that in this mode, the additional overhead on the source database is higher. There isn't like an overhead, I mean, in the source database, the capturing time. While the asynchronous CDC, in this mode, the change data will be captured once the transaction has completed, which means that it's not part of the transaction. And change data will be captured with the help of the redo logs. And in this mode, the CDC is dependent on the level of the supplemental logging that enabled on the source database. Supplemental logging add additional overhead to the source database, and it must carefully balance with the needs of the application for each using of the CDC. What does it mean? The supplemental logging, we will cover that soon, but I just want to add another thing about the read logs, that there are the files of the operation system that they are used by Oracle to maintain logs of all the transactions that performs against the database. Generally, they're used for instance recovery, and however, a readable-based application may require additional columns to be logged in the redo log, because in a way, only the change of a specific column will be captured at the capturing time. But we have, and if we want to add the rest of the columns to this log, we need to deal with something called supplemental logging. Supplemental logging is the feature along with streaming and CDC. It's available for a long time now, and it's used mainly as one of the integration options, especially for loading data from OLTP into the data warehouse. Now, we can set the supplemental logging in two levels. We have the database level, and if we want to have more, let's say, tight resolution, we can do it on the table level. But the database level, it's the minimal configuration required to enable the log of the update statement of the DML statement to be captured on the database. And if there is a key, a primary key exists on the table that the capturing was made, we will capture the primary key as well in the transaction log. Now, we have another setting that we can configure while we setting up the supplemental logging, and it all columns. It means, like I said before, that when we have a captured of one of the transaction, we're getting only the value of the specific column that have been changed. But sometimes we need to have a full view of all the row, of all the columns in the CDC transaction log. And for that, in order to get all the values, we need to set the all column feature on the supplemental logging. And it's in red and it's an optional thing for a reason, because we need to be aware about the impact on the source system while enabling such a configuration. Basically, it means that it will use a greater, more storage location on the source system and compute power. And this is something that's really important because, for example, now in our in this case of this customer, the Oracle DBA mentioned that we are not able to, we are not allowed to set this setting because this Oracle DB is actually an hardware on the data center. We limited our hardware, sorry, hardware in the, it's a limited hardware with a limited hardware in the data center. So we are, and they are worried about the consequences when setting those this configuration. Another thing to talk about is the Logminer. The Logminer is actually an Oracle API. It's a way to read the online reader logs and the archived reader logs from outside. And something that we're going to talk about it a bit later also. But the most important that it's deprecated on the newer version. We will talk about it also a little bit soon. Next, it's the AWS Database Migration Service. It's a cloud service that makes it easy to migrate a relational database, NoSQL database, and other type of data stores. You can use AWS DMS to migrate your data into AWS Cloud between on-premises instances or between combination of cloud and on-premises setups. There is no need to install any driver or application, and it does not require changes on the source databases, on the source database in most cases. You can begin the database migration with just few clicks in the AWS Management Console, and once the migration has started, DMS manage all the complexities of the migration process, including automatically replicating data change that occurred on the source database during the migration process. And you can also use this service for continuous data replication with the same simplicity. AWS DMS, it's a low-cost service. You only pay for the compute resource used during the migration process and any additional log storage. It helps you to migrate your database to AWS with no downtime or virtual downtime. That all data changes that the source database that occur during the migration are continuously replicating to the target, allowing the source database to be fully functional during the migration process. And after the data migration is completed and the target remains synchronized with the source as long as you choose to, allowing you to switch over to the new database in any convenient time. So during the migration and all the, let's say, the the main thing is that the source database are not getting any impact. It's highly available service. We'll talk about the architecture of it in a second. And it's secure. AWS DMS ensure that your data migration is secure. Data at rest is encrypted with KMS, Key Management Service. And during the migration, you can use SSL secure socket layer to encrypt in-flight data as it's travel between the source to the target. And one of the most important, it's monitored by CloudWatch. One of the things that are most important in data pipeline that you are able to get a notification as soon as a failure occurred. And DMS is the way of moving your data. And if something occurred on the way, we would like to get a notification if it's by email, SMS, and so on. So it's an important feature. Now let's see the resource that playing role in the DMS. In the middle, we can see the replication instance. It's basically an EC2 instance that the replication task is running on it. It's fully managed by AWS. Below, we can see the DMS replication task. And this is where we define the migration, including the type of the migration, what sorts of transformation if needed along the way. On the left side, we can see the sources that we can use and the target. And DMS actually support most widely used database. It support homogeneous migration, such as Oracle to Oracle, as well as heterogeneous migration between different data platforms, such as Oracle to Amazon Aurora. In this case, we sometimes need to make change on the existing database schema to match the target database engine. This task is usually require lots of manual work using expensive third-party tools, and we can use AWS schema conventions tool to enable those kind of migration. It's converting the source database schema to the format that fits to the vendor target database. Okay, so let's continue with AWS Glue. AWS Glue is a serverless data integration service that makes it easy to discover, prepare, and combine data for analytics. Glue provides all the capabilities needed for data integration, so you can start analyzing your data and putting it to use in minutes instead of months. It's fully managed ETL service that make it simple and cost-effective to categorize your data, clean it, enrich it, and move it reliably between various data stores and data streams. Under the hood, the ETL jobs use Apache Spark. Glue will spin up your own Spark cluster and actually execute those jobs for you. And since it's completely serverless and fully managed service, you don't have to worry about the underlying server at all. The output of the ETL job can write to S3 or even go to external database using JDBC connectors, and can be run on specific time, on demand, or even event trigger like dropping file in S3. And if there are any error in your ETL job, those will be reported to CloudWatch. And sorry, And from CloudWatch, you could actually integrate SNS to notify you with those errors automatically once they occurred. It contains a Glue data catalog. It can serve as a central metadata repository for your data lake in S3. It's able to discover schemas or table definition and publish those for use for analysis tools such Redshift, Athena, EMR, and so. Now, let's continue to our solution architecture, but before we diving into the small detail about how we have used each of the services and technologies within our solution, I want to show you the solution architecture. So the solution is powered by AWS infrastructure, which make it super easy for implementing such a solution. From the physical network layer to the database layer, AWS providing us a full comprehensive services to support this solution. Here on the right top, we can see, sorry, where the Oracle on the on the top right side, sorry, it's the client side where we can see the Oracle database is located. On the left side, it's the AWS side where we can see how the VPC is constructed and the different services that we used. The customer on-premise side is connected to AWS network infrastructure via a VPN tunnel which support a secured and encrypted connection tunnel between the customer side and AWS network. Via this tunnel, we will perform the data migration and transfer the data securely from the client to AWS infrastructure. And eventually, we will transfer the data to the cloud data warehouse to Snowflake. Here we can see in the middle the data, the DMS replication instance. It's crossed AZ for high availability in case of a failure. In the middle, we can see the DMS migration job. That in a way is an abstract object that describe the migration that's running on the replication instance. Eventually, the DMS will read the read logs from the Oracle DB. We will talk about it, how it's doing it, and will drop files to S3 bucket. And as the data pipeline goes, we will trigger an ETL job, a Glue ETL job, in order to process the changes from the S3 bucket using Spark connector and commit and merge those changes to a final table in Snowflake. Let's talk about stream Oracle changes to S3. The way we're moving the data from the on-prem to eventually files on the S3 bucket. So we use DMS migration task for that. We use the DMS. In this case, we use the CDC binary reader. Binary reader, it's an AWS tool that's reading directly the redo log, not from the Logminer. We'll cover it really soon in the next slide, but I just want you guys to be aware about it because, as I said, the Logminer is deprecated in the newer version of Oracle. And let's cover some challenges and limitations related to this part of the solution. So the files that are dropped into the S3 from the DMS, we have two kinds of files. We have the initial load and the CDC files. And the structure is different between them. We need to have our solution to support both of the mode. Oracle timestamp in second. We will see how it's affecting us. It's not in milliseconds, so if there was an update that made in the same time for the same item, we need to find a way to deal with that. There is not right way. There depends on the, let's say, business aspects. And when we're using it with S3, it enables the enable of the supplemental logging on all columns. It's a limitation because it's a limitation. We covered that in the supplemental logging presentation just before. And the last limitation here is the enabling supplemental logging on all columns. We've been asked not to enable supplemental logging on all columns, and just a small reminder what it is and what it do. And when it's on, when it's configured with all columns, then once change the code in one of the attributes of the row, we will get the CDC transaction log with a full, with all the values of all the attributes. And if it's not on, if we didn't enable it, then we're gonna get only the change for the specific attribute that got affected, and the rest of the attribute will populate with null value. This is something to keep in mind because on the migrate process, we need to solve this challenge because it's a challenge. Now let's continue with some. I promised you that we will talk about Logminer a little bit in deeper and DMS binary reader. In this case, we are using DMS binary reader because it has a lower impact on the source system, and we can see that. And actually, the Logminer, it's much easier to configure, and the binary reader, there are some more configuration that you need to configure, but eventually, Logminer is deprecated, and if you want to support this solution for quite long time, or if the Oracle version will change, it's better to use the binary reader in this case. And as we can see, yes, but the binary reader, we can get a better CDC performance, and it's supporting lob columns, and the main reason why we chose the binary reader on the Logminer, it's because the impact on the source system, and of course because it's deprecated. And another thing to say about Oracle, that we have this option for organization that want to have a proprietary solution. Oracle Golden Gate, it's a fully managed data cloud service that managed by Oracle. You can move your data in real time, reduce latency, and working that with scale. It's only committed transaction and enabled consistency. And of course, it's improving performance on the migration. And it has a minimal overhead on the underlying database of the infrastructure. Next in the data pipeline is merging data into Snowflake. So we used AWS Glue version 2, which features much faster ETL jobs. We triggered that by dropping file on the S3 bucket, and we manage that by Glue job bookmark. Glue job bookmark, it helps to process new data, then rerunning that on previous old data. It has like a pointer for each of the files that got processed, and like that it knows like exactly what files to process and what it doesn't need because it did it already. Okay, so next in our data pipeline is the merging part, and the merging data into Snowflake. We have used AWS Glue version 2 that features 10 times faster Spark ETL jobs. We triggered that by dropping a file on the S3 bucket, and it's managed by Glue job bookmark. Um, Actually, Glue job bookmark are used by AWS Glue jobs to process incremental data since the last job run, avoiding duplicated processing of old files. And like that, we didn't reprocess our old files and keep the old files in the same location. We have used external jars in the Glue job to connect to Snowflake in order to merge and actually the merge, we will talk about the merge in a second, but we needed a connector to work directly from Glue to Snowflake. With this JDBC connector, we were able to do that. We monitored all this ETL job with CloudWatch event, and we got notified by email if any failure happened on the way. And this is how we sync the change from all the S3 bucket to the Snowflake through a merge DML command on Snowflake. I'm not going to go deeper on the merge DML command, and it's related to Snowflake and off the scope of this um, webinar. But let's understand what the merging is doing, what we're doing in the merge. So basically, we have a stage table. With the Glue connector, with the Glue Spark connector to Snowflake, we are committing all our changes to a stage table, and then we're performing a merge operation to the target table from the stage table, dealing with the operation needed to do on the target. So we can see how we're reflecting the transaction log, the CDC transaction log on the left side to the right side. And also we can see, for example, with the problem with, or the challenge of the supplemental logging, where we had an update operation on item number 31, and the rest of the columns were null. So we needed to deal with this scenario too. One of the limitations that we mentioned before is the timestamp limitation in Oracle, and it's in second. And let's assume or imagine that we had the same operation on the same item, and because because a mistype of the high column. So from there, we are merging that we are moving this the data frame to the stage table, and we are actually not aware, or not that we are not aware, we cannot know what of those records are the right one, because we have no, if there we had so next will be in our limitation is the dealing with partial supplemental logging. We were not allowed to, we were needed to avoid setting the all column options that resulted nulls on the column which was not changed during this the operation, during the DML operation. And for example, the first we can see that we just update the high column, and after that we change the name column and then the age column, and but the rest were null, and we cannot commit those null to the end table. So we had like two ways to deal with that. Actually, we combined the two. First of all, on Spark, on the Glue ETL job with Spark framework, we were able to squash all those changes to one row, and then commit this and then commit the changes to Snowflake. And if we had a null of one of the field, we have a way in Snowflake to ignore the nulls, but it's taking a little bit processing time on Snowflake and on compute power on the Snowflake side. So we needed to squash it as much as possible in order to just working with the columns with the null values and not all of them. So let's summarize the challenge. The initial load, I didn't talk about it because actually it's a challenge, but you need to be aware about it more than it's a challenge, because if when you're writing your code, your Spark application code, you need to be aware that the initial load and the CDF files are different, and you can overcome this limitation by coding the right application for that. Timestamp resolution, as we said, because it was not a non-deterministic result, we chose just one of the entries, and it was okay with the business logic. Supplemental logging were not enabled on column, resulted sparse in data with the nulls, and we solved that in our ETL job within the power of the feature of Snowflake. Window function on the white table resulting Spark or out of memory. It's something that we got, like sometimes really wide tables with more than 200 columns within it, and we needed to filter all the relevant ones for us in the specific change that happened. So sometimes we got out of memory, but we were able to tune the Spark code and fine tune the Spark code as much as possible and get it to work as efficient as possible and limited with out of memory. And dynamic handling of new tables arriving to S3, something that we didn't talk about it, but it's really important for our next slide. We were able to work and actually to get new tables arriving to S3 without any need of our involvement. Every folder in S3 represented a table, and once we had a new folder in the S3, so we knew that we needed to create a new table on the Snowflake side, and like that we got a dynamic handling if new tables arrive. I talked about the last limitation because there is another alternative. While if you want to move your data from Oracle to Snowflake, and we can use something called Snowpipe. It's actually, we can use only Snowflake component in order to get the files from the S3 bucket. Just to say that the movement of the data from Oracle to the S3 was staying the same, but just the merging process from the S3 bucket to the Snowflake in this way is a bit different. And we can set something called a Snowpipe, which is an integrated component in Snowflake that can read files from the S3 as soon as they are landing in the S3 and performing a merge process to the end table by committing those changes to a stage table and using something called Snowflake Stream to record all the, it's like CDC, all the change that happened on the stage table from the file that came with Snowpipe, and with internal task to perform the merge to the table in the end of Snowflake. The thing is that it's a legit solution, but we chose the Spark solution because the Snowpipe solution require explicitly creating a pipe for each of the new table, and with the Spark code, it handle generic scenarios. We dealt with the sparse staging table with the null on also on the with the Spark code, and it was really hard to deal with it with the Snowpipe and the Snowflake components, and it was easier to implement data quality framework with Spark code rather than with Snowflake in this case. So this is actually it's a great alternative, but it was not fit for our solution. Okay, so next will be data testing, data validation. And in any data pipeline scenario, we want also to apply quality assurance in the form of data testing. In a replication scenario, replicating scenario, the initial thought can be that we just need to compare the table with some outer join. But it can be a problem if you are talking about large amount of data and wide tables. DMS also offer this kind of testing for you when the source and the data both supported databases, which is not in our case, but DMS documentation also warn you about this kind of check, saying it will require more resources and can impact the source database. Therefore, we want to be able to test the data quality without impacting the sources with large amount of data. We want to be able to test the quality on new batches of data in the destination alone. Also, we want to test the data in all the parts of the pipeline. For example, also in the small data frame we are merging. This requires us to understand what are the expectations of the data in the destination. We do that via profiling the data in the source. Here come Great Expectation. Great Expectation is an open source framework with rich SDK of data testing to ensure high quality data in data products. It provides automatic mechanism to get you started fast, like automatic data profiling and many predefined expectation. It also lets you define custom expectation and support inheritance. Moreover, it provides automatically built data dogs, reports, which are visual site serving expectation, suits data profiling, quality testing results, which give you a bird's eye view on the data quality, how it's changed over time. It supports many database sources as well as file-based sources in-memory data frame like Spark and Panda. And for databases, it's based on SQL Alchemy, which means it supports many databases. Among the databases supported are Redshift, Snowflake, MS SQL, and so. For file-based, it supports CSV files, Parquet, and can infer lake tables from metadata stores. Okay, so let's take a look at our data quality solution overview in high level. In our solution, we wanted to create several tiers of testing that will make sure that we not impact the source, but also not the target. We started with initial automatic profiling of the source table, which created very hermetic 100% fit to source expectation suits. Those expectation suits are saved in a central location In our case, it was S3, which can be a file system, a cloud storage, or a Git repo. We then began with iterating and relaxing those hermetic expectations. For example, removing an expectation that expect a specific row count, sorry, that will obviously would fail. We did this until we reach a stable yet strict expectation set that result in a successful validation for at least some of periodic of time. We are testing the data mainly in two places, in Snowflake and inside the merging job. Within the Spark job, we build a data context from the central location to have all the suits and the data sources defined inside Spark. We then validate the data frame and fail the job if the validation fails. This happens every time the job runs just before we push the data frame into Snowflake. In much less frequent schedule, we use Airflow to orchestrate and the validation of all tables on all the data. The Airflow job is using the same data context, for example, the same source of definition of the expectation suits, which make it very easy to update an expectation suit, knowing that we'll all inherit those from the same configuration. And this is how we implement our data quality insurance. Thank you guys, and I'm really, it was really fun. So this is the end. I really hope that you enjoyed this webinar as much as I did. And I want to thank you all for joining us once again. And if you have any questions, now it's the time. Thank you, guys.